Starting up the stream. Should be going pretty much now. Hi everyone, I'm TigerOcty3, and today we're going to continue with building our deck. So, I was thinking about this insert method offline, which is kind of long, actually, and I wrote a shorter one, which is over here. So, key parts. This bit we don't have to check two values because at this point we've already updated the index that we want. So here we have the zero case and the at the end, and here's our at the end, and our zero case is now just if not I. We're moving, and we do that by moving this to the top to turn a negative index into a positive one, and etc., etc. Okay, and then finding the node we want. This part I didn't do very well over here. We find the first one, and then we unpack and set it into there. No, we're gonna simplify all of this. Since we have established that it's not at the beginning or the end, it must be in the middle. So there will be at least one iteration of this, which means we can just do for index in range I, current equals next one of the iterator. And when that's done, that'll give us the current one. And then we can get the next one from there. And so instead of unpacking current and n, we're just going to get current in the loop, and then n will be the next one after that. And then instead of this stuff, I have a little bit of black magic, basically. I make a list with n, the next one, and the current node. And then I make a slice out of it from the beginning to the end, or the end to the beginning, because my step value will be either 1 or negative 1. And I have negative of current.next is n. So this is the identity check that I do over here, this sort of thing. Current.next. So if it is n, then it will be negative 1, and we'll flip that around. Or it might be 0, in which case we'll have negative 0, or, and then it'll default to 1. So if current.next is n, we'll have current and n, and then current goes into e.prior, and n goes into e.next. And this is our new node that we're making. And then we put e, our node that we made, into whichever thing ends up here for the next, and the other one is the prior for that one. So now that I've explained that, I'm going to put it in there. It's going to be a lot shorter. Great. So now that we've done that, I'm going to test it to make sure it works. It probably doesn't. I tested it with some other stuff, but I'm going to test it again. And now it's going to explode, and we will find out what I did wrong. Cow in chat says, Hey ASMR. Maybe. Might be. I sometimes type stuff and I talk. So let's run this and see what happens. It should be A, B, C, D, E, F, G, and then we'll put a 5 at -10 to +10. So we have 5 stays here, and then it's starting to move inside after C, after D, after E, after F, and after G, it should be at some point. Oh, no, -1. It'll be later. These are all with negative indices. So it'll be before the end, and then 0 is the beginning. 0, 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay, good. And then what do? We make an empty one, and we insert into the beginning a 0, and then right before that a 1, and then right before that a 2. Okay. Good. Cow wants me to tap my nails on the desk. I can... That's... I will be typing stuff at some point. I can also click and whatever. I only have the one microphone and the headset, so that's what I've got for now. And now that we've tested that and it actually works, wonder of wonders, in chat Methodora Ismail says, anyone here? And yes, there are people here. It is raining where I am, by the way. Just wanted to mention. So now that we've done this, there are other operations for which I will want to get the node I'm interested in and the ones next to it. So I'm going to make a helper function. Neighbors. That's not all I need. I'm going to need the index of what I want. Okay. So here is where we find the normalized index, basically. Let's copy it for now, not cut. Okay. And if I self.quantity, this is stuff that's unique to insert. We might want to delete, for example. Append and append left. If what have I got going on here? Okay. If etc. This tells us which this is how we will find the node. We'll need the rest of this block also. Could be good. Could be good. And then okay, we will need to find the next one. The next node. Okay. This is related to finding stuff. All right. This is good. This is good. Append. This is where we determine the iterator direction to use. This is where we basically scroll through the deck, and this is where we find out which one is the current one and which one is the next one. Okay. I'm going to change this forward name to 2 unique identifiers. Methodor Ismail says I need to print 0 at, I'm assuming 2, 99999. What command I write? That's actually many nines. How many nines is that? Out to 13 digits. Firstly, that will take a very, very long time to print. 1 times 10 to the 13 print calls. That'll take way too long. But try a for loop for I in range something, right? Let's see. Okay. We assign this to the first one is first, and the second one is second, right? Yeah. Let's call it A and B. Maybe. This is not recommended. Single letter variable names, because unless I, for example, refers to what I am doing, then we have no idea what it is. I, J, K, that sort of thing. N, E, A, B, you have no idea. There's a possibility, also E, we might know what that is. It might refer to math.e, the E mathematical value. But generally, no, we have no idea. How about before and after? Okay, acceptable. So now we will have to do something related to this, because remember here we said that by this point we know that it's not in the beginning or the end because we've already done that. Well, in this version we have not done that, so we will need to see what's up. So at this point, we will have some handling for this. It's not going to be exactly what we're doing here with the append, but it's going to be similar. I think it's not going to have this, but we're going to return something already. I plan to return the node before, the node, and the node after, in that order. Now, what if there is no node before or possibly after? Then, how about none? And then we can say, you know, if node, or if before, or if after. So, if not I, meaning if the index is 0, do I switch first and last? No. Okay. So we're going to return so we'll need none because there's nothing before. And how about this node? We might have to check for the length of the deck. I think we gotta do that. So if because we have a bool for this somewhere, right? Self-dot quantity. Let's just use self-dot quantity. It's faster. If we have a quantity of anything in here, what's a nice short way to handle this? None? None? It equals we don't need to decide on forward or back because we're just interested in the beginning. So we iterate. Current equals next one. Oh, no, I have possibly a better idea. Let's see. It equals self dot iter. So we make that, and then we do a try except. Then we'll say current equals next one of the iterator. Not a bare except, I didn't mean that. Except stop iteration, I think, happens with an empty generator. I'm just testing this out. Python is very wonderful in that it has an interactive interpreter. You don't have to create a file with a full class, etc., and then compile all these steps. You just kind of pop code in there. JavaScript has this too. Lua, F#, R, Lisp, not Java, not C or C++. Julia has one. What else? I don't know. We start that. Next E. Okay, there is a stop iteration. Get the next one of those. So we try to start this iterator, and if it doesn't work, then we say current equals none. And if it does work, and we do have a current, then we want the next one also. Operation, and n equals none. Very good. All right. If we're at the beginning, we'll also need to handle the end at some point. Self dot quantity. No, we don't want this part. Let's not do that yet. Self dot quantity. We should check for this, huh? If not I, or I equals self dot quantity for the beginning or end. Not I, this, else. Okay. Okay, good. So if we're at the beginning or end, oh, no. We don't want to go backwards like that. Do we? No. We don't. We really don't. We only go back if we're looking for one at the end, which we will eventually need. Let's keep it like that for now. For the beginning, then we want to go forwards and try to get the current node. And if there isn't, then we'll say it's none. But if there is, then how about the one after that? Or none. And after that's done, no, I don't need that. Then we'll return none is the previous one, which we won't have because it's 0. The index is 0. And then we want current and n. Very good. Let's do the following. Because really the before and after are just switched around if we go from the end. If not I, or I is the self dot quantity. We want to go backwards otherwise. And if we did the forwards one, this would be fine. But if we went backwards, we would have to switch it around. I know this is a lot of checks, if not I, but I don't really mind at the moment. Maybe I'll look at it later and be like, wow, I could have done this in half the lines, but not right now. Else return n current and none. We've got the this one and the next one. So the next one, n, would actually be the prior if we're going backwards. So we would have n and then current and then none. Yes. Should probably return that instead of just create it and throw it away. N, current, and none. Great. That's good. I think that's good. So what else? We don't need this over here, because this is just to get neighbors. Now this is if it's not at the beginning or end. Then we need to do stuff. We either go forwards, backwards, figure this out, etc. The next one. Next, we don't need to make a node, really. That should still be in there. Then we have before and after. And then we will return before. What's the current one? Just current? Yeah. Before, current, and after. So before, current, after equals self dot neighbors with I. Okay. So that gives us the node before and after, along with our node that we want. Now this here will change slightly if there's nothing before. Pen left and return. If there's nothing after, pen and return. Okay. Good so far. But at this point, we know that it's not at the very beginning or end, so we have to do this, make a node, and then we say e dot prior is before, e dot next is after, and I think I will do assignment, multiple assignment up here equals before and after. Prior next is before and after, and then before dot next after dot prior equals after prior equals e. So this is our e dot prior, e dot next equals, instead of forward, we have before and after. should we keep it as one object? No, I think this is fine because we want to check. We'd want to check our 0th element and then our element 2, and then let's how about will this work for an empty one? I think I think it will. None and none. Yeah, this should work. Okay. Let's get rid of all that. Great. So now all the insert method has to do is get the neighbors of this node and either put it at the beginning or the end, or just insert that node between its neighbors that we now know. And that will be handy for insert and also remove. And maybe indexing. I don't know about slicing, because that can yield a bunch of stuff. We might do that differently for slicing. The standard library collections.deque does not support slicing. Maybe ours will. I don't know, if we decide to put it in there. And now what do? We test, of course. And we find out what I did wrong. See? Right there. None current n, none current n. None current n. There was no n yet. Oh. Not I. Okay, we established that. We said we're going forward. Then we try to get the next one. And if they're... Oh. I see. If we have to stop immediately, if there isn't even one thing to get, then the current and next one are all none. Okay. Let's try that again. -10, 9, 8, 7, -6, -5, -4, -3, -2, -1, 0. 1, 2, 3, let's scroll down a bit. 4, 5, 6, and 7. Well, albeit it works with one error quickly fixed. I love those. Sometimes it takes forever to nail something down. Forever. Some things I haven't nailed down. If you've heard of the mobile game called Bleck, B-L-E-K, I implemented that a while ago for fun in Python and Deque.insert, and some things I still haven't quite figured out. One of the parts of the game is that there's something that rotates around, just kind of spins, and in mine, if you like reset it a bunch or like die and start over or something, something is weird with the timers and the scheduled callbacks, that sometimes it like doesn't cancel the old one before starting up the next one, and so you get instead of one call every X milliseconds to turn the thing a little bit, 1 degree or whatever, you get 2 of them. So it goes 2, so it goes twice as fast. And then you like die or reset again or something, and first it goes slowly, and then it goes a little faster, and then sometimes. Is it that one, or is it just the arrows? It's supposed to like launch an arrow at something, and sometimes the arrow stretches out as it goes. I really don't know. It might be something to do with floating point math or square roots. I don't know, but it's close enough, and it's not a production game. I just spent a week having a good time. That's the fun part of games, writing them. So this works. We can get the neighbors of an item at a certain index. Now we do need the index. That is important. The remove method for a standard library collections.deque does not use an index. It has it operates on the value of the element. So it's like remove from a set, or I think from a list. Has it too. Is it remove for all of them? Yeah. So remove, as you also have with a list and a set, finds an element with the value you gave it and takes it out. It's not going by the index of it. Like if you had a list with Alice, Bob, Charlie, and you wanted to remove Charlie, you could do del mylist brackets 2, and that would be the index of 2 of your list. Or you could do mylist.remove Charlie, and then it would go through it and say, this isn't Charlie, this isn't Charlie, this one's Charlie, remove from the list. So remove does not use an index. We will figure that out when we get to it. So neighbors is large, but it's pretty useful. So it's going to stay there for now. Now insert is a lot shorter. And what else will we do? Insert we've done. I think it was remove and rotate. Did we already do index? Remove and rotate are paths right now. I think it's just remove and rotate. So remove the first occurrence of value. Let's do that. Remove the first occurrence of value. Remove. For, let's see. Okay, we get a value error if it's not in the list. In the deck. Sorry. For node in self.iter. Let's just go forward. I don't care. Because this hasn't given us any hints as to where it is. So we don't know whether to go from the beginning or the end or whatever. We're just going to go through it and remove. If node.element equals item, we want to say the prior node points to this. First, we gotta make a node. Make a node out of the element, and then say e.prior, e.next. Equals. No. We want. This is not an insert. What am I doing? What am I doing? If we've found the item, then we want to say the next node points to the prior one, and the prior one points to the next one. If node.prior, so if there's something before, then the one before now points to the one next to it. Yeah. Node.prior.next equals node.next. And if there's something after this one, after this node that we're removing, then we say node.next.prior equals node.prior. The next node's previous node is no longer this one. The next node's previous node is the one before. Is that it? And return. And then if we haven't found it, raise what's it called? Value error. Item. Want the repro. Not in Deque. What the heck am I doing with the syntax? That's not how that works. There we go. Okay. D dot remove about B and print D. D dot remove something at the beginning, and D dot remove 5 will be at the end by this point. Okay. And then at the very end, with this new one that has 0, 2, 1, we will D dot remove 8, which is not in there. Okay. Now let's see what happens. Oops. In other languages, this would run fine, and it would be wrong, because what it would do is it would say if, see I have one equal sign, which is an assignment, not an equality check. It would do if, and then it would assign item to node.element. Instead of checking whether they equal, it would just put it there and say now they are equal. And then it would remove it. So if we had a first node starting with an element of the string A, and we were looking for, if we were looking to remove 3 and not A, instead of doing is A the same as 3, it would do, this node now has a 3, and let's remove it. So there would be no error. It would just remove the first item every time. We don't want that. Okay. Seven, 8, 9. And then we removed B, and then A, and then 5. We removed B, so that's A, C, D. And then, uh-oh. A is still in there. But it removed 5, so something is disallowing us from removing the A. For node in self.iter, if node.element is equal to the item, if there's a prior one, then we say the prior's next one is node.next. Why didn't that work? Okay, if there's a node.prior, and there isn't, let's do the following. Print node.element and the item. Okay, great. Let's run that again. Okay. B and B, there is a prior, there is a next. A and A, there's no prior, but there is a next. And A wasn't removed. Why not? So this printed stuff, it was A, and we found A. There's no prior one, which is good, because node.prior would not have would have been none if it wasn't. So if there is a prior one, we will say the prior one's next is node.next. There isn't. There is a node.next, and we say next. And we make the next prior one. Oh, not node.prior. We want it to equal the node. No. Yeah, node.prior. Should have been none. Oh, it is none, but the first item of the list is still this thing, isn't it? First. Okay. That's wrong. So this is affecting first and last. Did we remove the last item at some point? Remove the 5. Let's check that. It did remove the 5. Why did that work? Is this first and last stuff broken? Append. Pop. Oh, I think I know what's happening. We never ever change it anywhere else. Okay, that's wrong. Because we do use that, and we keep track of that. Because we need to know which one is the first one and the last one. We have to have some reference to some reference to the nodes in our deck. But Copy count. Does this increase the count of the list? It doesn't. We should do that. Make that correct. Remove -1. Okay. When we insert, self.append left and self.append do take care of that, because append and append left have, they do handle last and first stuff. Okay. But when it is not, that should be fine. I think it's remove itself that's a problem. Right here. If there is something before, then we want to adjust this prior node's next one. But if there isn't, then we say there needs to be a new first one. Okay. And let's take out these things. That wasn't too hard to troubleshoot. Pretty good. If there's a node, then we'll make that node point to the one after the thing we're removing. But if there isn't, then self.first is going to have to be how do we know if there's a next? Node.next. Whatever's after this node. If this node was also the end, then the first will be none. That's fine. Else self.last equals node.prior. I sense something that I can do here. Maybe? No. Because I'm assigning to something different. If I was assigning possibly different values to one variable, result equals this or result equals that, then I could streamline that. But assigning to something different, no. I could put both on one side and then have something to unpack on the right and then flip it around or something. This is good. This is fine. This is fine. We remove the B, then we remove the A, then we remove the 5. And raise value error. Okay. I wish it didn't like show me all this stuff. It could just like do this. But narp. So what now? Let's remove rotate. Rotate the deck n steps to the right. If n is negative, rotate to the left. Rotating one step to the right is equivalent to d.append left, d.pop. Okay. Let's open our let's check it out. Interactive interpreter session. Great. What's our deck? A, B, C, 5, D, E, F, G. Okay. Let's tidy things up. Okay. Very good. D dot rotate 0. It's the same. D dot rotate 1. What is it now? The P went from the end to the beginning before the A. Okay. -1. And now we're back. What happens if we do 5? So LMNOP is now on this side, and it's 5 items. Now we have that. What if we do that again? Will we have the A, B, C, D, E on the right? Yep. So, we can't exactly just have a loop where we append whatever we popped, because that would reverse the order. Instead of having A, B, C, D, E at the end, if we first pop A, can we? A, B, C. If we have this, E, B, I think that's what this is going to be. I thought it would reverse the order, but no. Okay, we're back to our starting point. Line range 5. And this would and rotate 5 takes items from the right and puts them on the left. D dot append left. D dot pop. Something's weird. What did I do? JK. Oh, yeah. And let's do append and pop left. Should be the other direction. Yeah. Let's do that again. And see, and now I have it. Okay. So that's all it is. This has to handle negative numbers. If it's too large, what happens? Probably just does a modulo operation, finds that out. D dot rotate 100. Okay, great. So here's what we will do. We need a value of some kind. And then I mod equals self dot quantity. Okay, that means I equals I mod self dot quantity, and that's we get I and we divide it by the length of our deck, and we set I to the remainder of that operation. So if I is smaller than the size of the deck, it will be itself still, and if it's larger, it'll be whatever remains. If the size of our deck is 5 and we have an I of 6, then after this I is 1. How about for negative numbers? Does that work the way I think it does? Let's say we have a deck of length 5, and we give it -6. That would mean we want -1. -6 mod 5 is 4. Which would be the same as -1 from the other direction. Maybe we should optimize for finding the smaller one? Yes. Something with the minimum, what's it? The same way we want to, when we insert, we wanted to find which direction to go from. We also want to find which direction to go from here. Because if someone says, I have a deck of 100 items, and I want to rotate, one item off the end, that's easier than going all the way the other direction, right? So, -6. Oh, no. 6. What's the precedence of this? Oh, okay. I thought it was messing me up because the exponentiation operator has higher precedence than the negation unary operator. 2 to the 5 is 32. -2 to the 5 isn't -2 to the 5th power, -2 times -2 times -2, etc. It's negative whatever 2 to the 5 is, so -32. But if we do this, that was not a good example, was it? 4? Does 4 do that? Is that the issue? There we go. -16 and +16. So, let's add some logic for figuring out which end we should work with. I think this will actually work for this part, I mod equals self.quantity, because instead of -1, we'll have 4, which is fine. Now we just have to figure out which end we are going from. Okay. Let's see. How do we do that? We want to see whether it's closer to the beginning or end. How about think. Similar to what I did in something somewhere, this thing. If it's less than half the quantity, then we want to go. What do we want to do? What's our deck? We have dot rotate 1 puts the item from the end onto the beginning. So this is pop and append left. Self.pop and append left. Okay. And this is when we do want to go forward with just the regular I, whatever it is. And if it isn't, then A equals self dot pop left, correct? And B equals self dot append. Let's double check that. D dot rotate -1. We're going to pop left the A and append that onto the end. Yeah. Okay. I'm going to call this pop and append. Without having to worry about the... I'm just reassigning the pop or append methods for the specific direction, so I can just say, you know, pop, the append, whatever. Okay. That didn't make much sense, but instead of having to say, if it's one thing, then for I in range, whatever, pop and append left, else for I in range, whatever, pop left and append. Now I can just say, whatever function I need to do, this is the function that I need to call. And otherwise, I'm going from the other end, and it's I equals self dot quantity minus I. Okay. Sorry about that. And then after, we want to go from the for something in range I. Append the pop. Is that it? I think that's it. Okay, let's change our testing. What's it? We can take out all this. We're going to take out everything. DQ with, I don't know, A, B, C, D, E. How about? D dot rotate 1. D dot rotate -1. What do I do for 0? If not, I return. There we go. Optimize. 1 and -1. So that should do 1 1, and that takes something from the end and puts it at the beginning, and -1 will put it back on the end. And then we'll, how about do d dot rotate 3. For I in 1, -1, 3, -3, 5, -5, 10, -10, I don't know. Rotate I, and print D. Okay. So we'll have A, B, C, D, E. We'll put E from the end into the beginning, so we'll have E, A, B, C, D. Let's write this out. First it will print E. Let's do this, actually. E, A, B, C, D, and then A, B, C, D, E, because we fix it. And then 3 from the end is C, D, E, A, B. And then we'll put it back, A, B, C, D, E. And then 5 would be the same. Let's do let's just change these to 7. And this is going after this part. We're going to normalize it. If we have a deck of length 10, and we say to rotate it 10 or -10, that'll give us the same object again. So we're going to normalize it first, and then we're going to see if we don't have to do anything. 1 and -1, 3, and then -3, and then 7 is 1, 2, 3, 4, 5 is going to be the same as 2. So D, E, A, B, C, and then A, B, C, D, E. Okay. I turn this off, I turn this on, and what in the world did I do? This is very bad. Very bad. Why does this not work? Can I not print sturdy? Pretty sure the other thing. Nope, nope. Something's wrong there. Something in here is bad. Why can I no longer print the thing? I could before, right? Okay. But then I rotate it, and it doesn't work. Something exploded. string representation of this thing is really not happy. Oh. It's printing the nodes, not the elements. How do I get it to do what I want? That's a good question. No, it did it with just the regular one too, huh? With just this. Didn't like that one either. D.rotate. What's wrong with rotate? I don't know. Let's try rotate 0. It should still work. Rotate 1. Is this gonna break? Oh. What am I doing? Why didn't that work? Seriously. Should have been self.append left, self.pop. Something. But see, we have... That's odd. ABC, A, B, C, D, and E. We have a deck with a deck inside it. That's very strange. Something with this is very bad. Something of... Why doesn't that work? Self.append. Self.pop. Append left, self.pop, or self. That's very strange. I don't know why that's not working yet. But it's adding a deck. Is that an empty node? Repro of the element. It appended itself to itself? What in the heck is happening? I really don't know why it's doing that. Let's do it manually instead. Self.append left, self.pop. Or something in range I. This one, thanks. That gets commented out. For nothing in range I. Etc. and so forth. I really don't know why it's doing that. still doing that. This is very strange. Oh, I know what the problem is. Because it had to be a special snowflake and say my pop method will return itself. Or a tuple of it, of the deck and the item I popped, and append will return the deck and the item. So this was fine. The actual problem with this was these special snowflakes that are very special and will now no longer be special because I gotta actually use them for stuff. Pop should return. No, this is append over the max line. Append shouldn't return anything. Pop should return only the element. Append shouldn't return anything. Pop should return only the element. Great. Perfect. Crikey. I want to keep those there. Okay. Let's try it again. E, A, B, C, D. A, B, C, D, E. C, D, E, A, B. A, B, C, D, E. D, E, A, B, C. A, B, C, D, E. And I can do this like I wanted to. Great. Perfect. The lesson today, of course, is that if you are going to make your code be a special snowflake, you should remember that you did that. That's the key. That's why I didn't know why it was doing that. Because I didn't remember that my append and pop methods were crazy. Because I want to do, you know, method chaining dot pop 0. It's like, but then you can't do, you know, append what you pop. And I wouldn't be able to do this. Technically, there's probably a better way, because what this thing I've highlighted does is it pops something off the deck, so it removes a node and gets the element, so that's breaking a connection, and then it puts it onto the beginning, making another node, etc. When what I really could do, what I should do, what I should do is I should just say, just break the connection somewhere and reconnect it elsewhere. That's what I should do. Not any of this stuff. I'm equals self.quantity. All this stuff is going away. Now that we've tested it and seen that it works, we're not going to use it. Because I'm just going to segment it off, do it once. Of course, I have to find that element first with the neighbors. Yes. Okay. How do I do that? Neighbors. This gives me a 3 tuple of before, current, and after with an index. So I'm still going to have to go through the deck to find which node is, moving around and stuff. But I'm going to go through it, and instead of... Is it faster to go through it? I think it is. Yeah. Does it even matter? I tell you what. We are going to test it. See which one works better. Okay. And getting the neighbors works with something like this. Okay. So we have the one before, current, and after. Then no, this is the, this is the number. I have to do something with math here, which I will figure out. Math. I have to find the index. It's not exactly going to be I necessarily. Will it? We did, 0 is nothing. But if we do 1, it takes 1 item off the end. And if it's -1, it's 1 off the beginning. Okay, I think we have to invert that to match the actual index of where things are happening. I would be self.quantity minus I. So if it's a deck of length 10 and we have a rotate of 1, then that would be 10 minus 1, that's 9, that's index 9, that's the last one. And that one, we basically cut off everything before, and we move it to the beginning. And we say that's that. Okay. Do we need this? Actually, I don't know. Yeah, it would be good to, I'll need that. Okay. Now we have basically an index, not an amount to move, really. For current and after. If there's something before, then that one is now the end. self.next equals none. Okay. And there will be, I believe. Can we do something mod 0? We can't. That's a 0 division error. If not, self.quantity return. Okay. Without that, if we try doing this on an empty deck, it would give a 0 division error because we're modulus is a dividing by 0 and giving us the remainder. Integer division or modulo by 0. 3 mod 0, can't do that. This thing. So we get an error. The one before is now the last, and that node's next is nothing. There would have to be something before, wouldn't there? If there is nothing before, it would mean we're taking the whole thing and rotating itself. That's not going to happen. That's not going to happen. It just won't. Last one is now whatever we had before. And before.next equals none. And how about after? Do we use after? No. Oh, this has to go later. Because we're going to save the old last node, and we're going to say this is now together with the front. And the first is going to change as well. Before.next is none. Okay, so we've severed that. Equals the old self.last. No, is the current thing we wanted. Yeah. The old current node that we selected is now in front, and the one before it is now last. But we're going to do that later because we need to access the previous ones. So we move that over, and we say the first one now has a prior one, and the first one points to what was the old last one, and the last one points to what was the old first one. Self.last.next equals self.first. self.first.prior gets self.last. Is that it? I think that's pretty good. And we won't necessarily use what's after. Okay. So we have a deck of length at least 1, and we have a rotation of at least 1. Let's look at our old one. We got the results we want. What happens when we do rotate 2? Horrible problem. E, A, B, C, D. Something is wrong. Okay. Great. The 1 worked, and then we tried to do -1, and it was not happy. E, and then something went wrong. Okay. Let's work with -1, something. This might be incorrect for the rotate 2. We either want to remove 1 or -1, meaning from the beginning. Oh. Is this I minus quantity? What's actually going on here? If we have rotate 1, that means we want the length of the deck minus 1. But if we have -1, then that means we want basically +1? No. -1, yeah, means we want +1. So this might be wrong. Okay, let's fix this. If it's 1, we want 9. We want the smaller of this or the absolute value of I, right? If it's 1, we just want something from the end, and we say index. Would it be easier to go the other direction? I don't know. I don't think so. If it's 1, we want something. If we have a deck of length 10, we want 1. That means 1 from the end. So 10 minus 1, 9. And if it's -1, we want +1. How about that? No. Isn't this supposed to handle a stop iteration? N equals next iterator. Oh, maybe there isn't one. But didn't we handle the case of not having something at the end? If not I, or I select quantity. If not I, we do this. Otherwise, we do that. Try accept this. If it works, we do that. If not I, return non-current n. Else, we return something else. Next in range next. It's the n equals next iterator that it has a problem with. Why? It wasn't at the beginning or the end. We make our iterator. We say some number of this. Star, okay. Some number of this. This was working, wasn't it? I'm pretty sure. We get the next one. Maybe there isn't. Okay, it could be in the middle of something with 3, and then it would have a next one, but then not another one. Okay. No? Current equals I no longer know if this is right or not. If we have 1, then our current will be the first one. Something is wrong here. Here's what I'll do. Here's what I'll do. Don't put imports in the middle of your file, by the way. And what was I doing with this? I want to make sure they behave the same with insert. Range -7 to 7. And I want to do D.insert a 5. Insert at I a 5. Insert at I 5, and then print D and E. Five A B C D E 5 5 5, and then A5. These are all the same. So that's okay. I must be doing something else wrong. Okay. Doop doo doop doo doo. Back we go. Okay. Something's messed up here. Why did it say there's no next one of this? When I said neighbors of I. I think it was -1 that didn't work. Nope. Maybe it's this that messed it up. Nope. Oh, rotate, not rotate 2. My bad. Rotate 2. Only prints that one. That's wrong. This should have taken the A and put it at the end, basically. Or taken, you know, everything and put it in the beginning, depending on how you look at that. Why isn't that working? I've been at this for almost 2 hours. I would have liked to have this working properly, but I don't know, man. Did I have anything else I wanted to do? I got remove and rotate. I just wanna finish rotate and make that good. If there's no deck, return. I'm on sorted quantity, return. Let's do some testing. Deck length equals 5. Let's say we're past 1. Mod 5 and 5 is 1. Min of 5 minus 1 and absolute value of 1 is 1. So that's wrong. For that, I would have wanted something else, wouldn't I? Okay. I take the modulo, and going one way is the same as going 4 the other way. Something is weird with this part, I'm pretty sure. Because I'm trying to convert a distance that we're moving, like quantity that we're rotating, to an index. And it's a problem with negative values. Let's not give it negative values and see what happens. Let's see if it works for positive values. Not on this one. This one. No. Totally broken. Okay. That's not cool. But I know that we can get the neighbors because it works for insert. And do we use it for remove? No, we don't. So I think it is a problem with figuring out I, possibly. Let's do the following. L is going to be, is there anything in L? I don't need that. L equals, 1, -1. How about we just use a range from negative to positive 10 for our deck length of 5. Troubleshooting. Let's see. If I have, let's write down what I want it to be. If we rotate 1, that index should be length of the thing minus 1. -1 should be 1. Maybe I need the thing from get neighbors or something. Yeah, it doesn't like, this is converting an index. So we need to pass it a valid index of something. 1 is length minus 1, is where we cut it off, and 1 would be, or -1 would be 1. What else? Let's do def f of I mod equals dlen. I can do that. And then return this. Which would be abs I. Okay. F of 1 should be 4. That's not right. What? That's very strange. Okay, I had something wrong there. I will have to change that. For I in range -10, -10, +10, print -1 mod I. I don't know what I'm doing, really. Oh, and that one is... This is not super helpful. I'm trying to figure out how to convert these things to a proper index, and I don't think I'm doing that. Let's say we pass it an index of oh dear. What a mess. This one worked fine. It was really simple. Once I fixed, you know, the pop and append stuff to actually do what I thought they would. What is it? I don't know. I don't currently know what the problem is. Let's assume for now that I is correct. Before, current, and after is the neighbors of I. Before dot next needs to get none. And the last one now has a next of the first one. And the first one's prior one is now the last one. And the actual first one now is whatever we specified as the current one. And the last one is the one before, I think. Last. I might have to draw pictures. I don't know. Last now points to the first, and the first points back to the last. Do I change the current? I don't need to change the current dot next one, but I do need to change the current dot prior. Because now the current dot prior equals none. And the last self dot before dot next equals none. For the I, now let's look at the I also. If it's Oh, abs isn't going to happen because this always produces a positive number. So 1 is still 1. Let's say we have a deck length of 5. 1 would give us 1, but negative 1 would give us 4. I don't think that's what we had in mind with this stuff. There's no need to do absolute value because it'll never be negative. That's just wrong. I think we're almost at the answer to resolve this. Should we invert it? I'm going to change this is the distance from the end. So I can just make it negative. Negative I mod subject quantity. Okay. And then the neighbors method will convert that for us. Okay. Let's see what happens. Not in this one. In that one. Kablooey. I don't know why. I thought I had fixed it, but no. Let's make another little function to test this. We want negative I mod something. F I quantity return if quantity return negative I mod quantity. If we give it 1 with the length of 5, that would be negative 1 from the end. If we give it negative 1 and 5, that should give us negative 4. Okay. How about negative 8? No. This does have to be changed, because that might not, I don't think that's right. Is it? Negative 10, 0. Negative 9 is like a negative 1. What's D? D dot rotate. negative length of D plus 1. And that's like negative 1. F of negative 6 with 5 should give us basically negative 1. It doesn't. So this is still wrong. Still wrong. Okay. Still wrong. How do we do that? How do we get this I to be correct? I don't know. There's got to be something, but I don't know what it is. I don't know how to do that. Also, this has been going for over 2 hours. So here's what I'm going to do. And does this still work? Yeah. And we are done for the day. Our other rotate will have to wait till next time, because right now I have no idea. I just have no idea. So, next time, this thing, I hope. I don't really know what's wrong with it yet, but hopefully we can figure something out. And hopefully it's actually worth it. Hopefully it's faster. Because I would like to figure it out. Should be faster. Just accessing a next and a next and a next, instead of destroying a node, creating another one over and over again. Should be faster. I don't know. I don't node. So, that's what we've got. Rotate 2 doesn't work, don't use it. But we changed a bunch of other stuff. We changed the append, pop, append left, and pop left to do what they should. We added the neighbors method, changed insert, added remove, and rotate, and started on rotate 2. Doesn't work yet. And that is my stream for today. Thank you for joining me. I hope to see you again next time, and have a good one.